Hello everyone, welcome to Tector.com. So in this lecture, before we go and start matrix, we will understand the properties of determinant. If a question comes from determinant, it must be somewhere from this lecture only. Okay, so they can twist the property and they can ask some question depending upon these properties. So let's understand it. Okay, so the determinant properties, we will start with very simple property. The first property is if we exchange the rows and the columns of a determinant, that is what I want to say, that if we have 2 3 4 5, okay, so this is our first row and this is our second row, and if we exchange means the row is exchanged by columns and column by rows, means if we make it 2, then this 3 and 4 5. Okay, so we have interchanged the row into columns and columns into row, so this is called basically transpose. Okay, so this is transpose represented by this. We will study this in matrix also. So the determinant of A transpose is basically equal to the determinant of the original value of determinant. Okay, so it was first property. Now let's understand the second property. Okay, so this is our second property. If any row or column of a matrix is 0, then the matrix the determinant will be 0. Sorry, I'm saying matrix. If any row or column of a determinant, for example, if it is 0 0 0 0 and then all values like 7 8 9 6 5 3 2 1 7 6 2 5, something like this. Okay, so even if it is a huge determinant, but if all the values here from a row are zeros, okay, then the value of determinant will be 0. Okay, it's very simple, we all know this, it's just a purpose of revision. Okay, so similarly, if all the columns, for example some column is 0, then in that case also the value of determinant will be 0. Okay, let's go to third property. If a determinant have identical rows or column, the value of determinant will be 0. What I mean to say is, if we have something like this, let's start 6 5 3 2 9 7 6 5 3. If you see this determinant, we have this row and this row identical, right? So in this case the value of determinant will be 0. We need not to compute it, we know that the value of determinant will be 0. How, we will see. Okay, so the next property is if the value of a determinant or the if a row or a column of a determinant are added multiple times to another row or column, the value of determinant will be unchanged. Okay, so what I want to say is, if we have a determinant 7 6 2 1, okay, now what we do is we just add this row to the first row, for example 2 times. So what will be the determinant now? The A will become, or the determinant will become 7 4 11 6 2 8 2 1. Fine, now let's compute the value. So here the value will be 7 minus 12, that is minus 5, and here the value will be 11 minus 16, that is minus 5. Well, so it means that if we add, or even in case of subtract, so if we add or subtract a row or a column to another row or column multiple times, the value of determinant will be unchanged. Fine, so let's come to the next property. Okay, so the next property is multiple with scalar. what does it mean when we multiply the whole determinant with a constant k? What will be the change in the value? That we have to understand. So there are two kind of multiplication. If we multiply each element of a determinant by k, for example k a11, k a12, k 2 a21, a22. Okay, so here what we are doing is we are multiplying one each element of a row with k. Okay, so the value of determinant will be basically k times the original determinant. Okay, it is a k times the original determinant. Okay, but if we multiply each element of a determinant, for example a11, a12, a13, a21, a22, a23, a31, a32, a33. Well, if we multiply each element by k, 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 okay, then the value of determinant will be k to the power n times of original determinant, where n is what? Order of determinant. Okay, so if you consider both of the two examples, they are correlated, because see here, if we multiply each row of each element of a row with a element constant k, we are getting 1k outside, right? So similarly we have nk for determinant of order n. Okay, so nk will be outside, k, that is n times from each row 1k will come out. Okay, so this will turn out to be k to the power n, and then the multiplied with the original value of determinant. Okay, so this was fourth property. Now let's come to the next property, that is fifth property. So here we have next property, product with cofactor. So basically this is product of an element with its cofactor. So in a determinant, the sum of the product of the element of all the elements of a row with its cofactor gives the original value of determinant. I also explained this in cofactor. What I'm saying is, for example a11, a11, a12, a21, a22. Okay, this. So I'm saying the product, the sum of product of let's repeat it again, sum of each element of determinant of a row with its cofactor gives the original value of determinant. What I want to say, a11 into cofactor of a11 plus a12 into cofactor of this is cofactor of a12, okay, will give you the original value of determinant. Okay, so this is product with cofactor. But if we multiply a element with with the other row's cofactor, other elements, for example a11 into cofactor of a21 plus a22, a12 into cofactor of a22, this will give you 0. Okay, what I'm saying is the multiplication, the sum of multiplication with its own cofactor of each element of a row will give you the value of determinant, but with the other element's cofactor, means you are multiplying a11 with the cofactor of a21. Okay, and then you are summing it with the multiple of a11 and cofactor of a12 and the cofactor of a22. Okay, in this case the value will come out to be 0. Okay, fine. So next property says for two determinant A and B, okay, the value of A into B and then its determinant. For example, you multiply A and B and then you find out the determinant value is equal to basically multiplication of individual determinant and its multiplication. I mean the value of individual determinants and its multiplication. Okay, so AB determinant is equal to determinant A into determinant B. Okay, fine. Now we can also say that the determinant of A inverse, basically this is A and B are matrices, we will be covering it later. So A inverse and determinant is equal to 1 by A. Okay, so these are two important properties you have to remember. It will you will have application of this in various problems. Fine. So what I said is that you multiply these two matrices A, B and then find out the determinant. It will be equal to the individual determinants and its multiplication. Okay, here A inverse determinant. Okay, so you find out A inverse of a matrix A and then find out the determinant will be equal to 1 by A. Well, so let's come to the next property, which is adjoint A. Adjoint A equal to A to the power n minus 1. Adjoint A we haven't understood yet, but uh, in short I'll say adjoint A is equal to the cofactor, corresponding cofactors of A and then its transpose. What I want to say is, for example, if you have A11, A12, A22, A21, A22, fine. So you replace each element with its cofactor here. Okay, so first you replace each element with cofactor, which is A11, A12, A21, A22, fine. And then you find out the transpose of it. Transpose means you exchange the rows and columns. Okay, so that is A11, then A12, A21, A22. Okay, so this will be transpose. Okay, this will be transpose of matrix, I mean this will be adjoint. Okay, this is adjoint. First you find out cofactor and then transpose. Okay, so the property is adjoint A, determinant of adjoint A is equal to n minus 1th power of original element. It means as we know, and we have turned out this result from here, that A into adjoint A equal to determinant A into identity matrix. Okay, so from here we know that this is adjoint of A equal to determinant A and upon A, fine, and this is I. Okay, which turn out to be, if we find out now determinant both side, it will be A to the power n minus 1, I mean the original value to the power n minus 1. Okay, so this is our last property, and these all properties are very important. We have to keep these properties always ready in our mind to implement. So the questions may be asked from uh, the implementation of these properties, not direct question on these properties. Okay, so I hope you understand it. If you have any doubt, ask your question in doubt section. See you in the next lecture. Thanks for watching.